Hey there folks, Mike coming back at you once again with another video on precalculus. In the previous video we talked about the logarithmic function. It is the inverse of the exponential function. We talked about some of the properties of the logarithmic function. We talked about how to convert between logarithmic and exponential form, and then we just stated some of the more common logarithmic functions that we typically see in the real world. In this video, we're going to talk about some properties of logarithms. These are very, very key, very critical properties that you will want to know how to use. If you can master these properties of logarithms and know how and use them to expand or condense logarithms, your future math classes will be so much easier. So there are three main properties that we are going to talk about in this video. The first one is the product rule for logarithms. These three properties hold no matter what base b you have. The product rule basically says that the log of the product of two things is equal to the sum of the individual logs of those things. So log base b of mn is equal to log base b of m plus log base b of n. The second property, the quotient property or quotient rule for logs, says that the log of the quotient of two things is equal to the difference in their individual logs. So log base b of m over n is equal to log base b of m minus log base b of n. And third property, the power property or power rule, which says if you have the log of something raised to a power, you can take that power that's on the thing that's inside of your logarithm and pull that power out front. So log base b of the quantity m raised to the power p is equal to p times log base b of m. Now, I want to be very clear here. You can only use this property, you can only use this rule when the power is on something that's inside of your logarithm. If you have the entire logarithm being raised to some power, you cannot use this property. So if I had, say, log base b of m, and this whole thing raised to the p, I cannot pull that power out front. I cannot say this is equal to p times log base b of m. No good, cannot do that. These properties, as I said, are used to expand one logarithm into the difference or sum of several logs. They can also be used to condense several logarithms into one. Now, we have this product property, quotient property, and power property, but what order do we use these properties in based on what we're trying to do? And there's a nice little picture we can draw. The order is either going to go quotient, then product, then power, or it's going to go power, then product, then quotient. So we have these three properties listed out here. The question is, which way do we go based on which operation we are doing? And if we are going to take a single logarithm and expand it into the difference or sum of multiple, we're going to first use our quotient property, then we're going to use our quotient, then our product property if we have to, and then we use the power property. If we're going to take the difference or sum of multiple logs and condense them into one, we're going to start by using our power property, then we go on to the product, and then we wrap it up with the quotient property. So we're going to see some samples of going both ways, expanding logs as well as condensing logs. So we'll start off by expanding each single logarithm here. And we're going to express all powers as factors. So, as I just said, we are expanding here. So we're going to start with the quotient property. If you're seeing a quotient inside of your logarithm, like we clearly are here, you're first going to use that quotient property and say, okay, log of everything on top divided by everything on bottom equals log of everything on top minus log of everything that's on the bottom. So when you do that, the use of quotient property says that this right here is equal to this line right here. Log base 2 of x cubed times the quantity y plus z squared minus log base 2 of the quantity w plus 1 raised to the 5th power. So that's the only quotient we had here. There's no other fractions happening, so we're done with our quotient property. Next up, going back, we use the product property. So we take a look at this thing here. We notice that in here, we're taking the product of two things. We're taking the product of the x cubed as well as the y plus z squared. So we're going to use the product property on this guy. Note that there's no product here. It's just one thing being raised to a power, so we don't have to mess with that. But this right here will equal log base 2 of x cubed plus log base 2 of y plus z, that quantity squared. The log of the product of these two things is equal to the sum of the logs of each piece separately. So that's the only product that we had to work with here. Product property is now done. Now we go on to our power property. So we see we have exponents on these things here. These exponents are on the thing that's inside of the log, not on the entire log itself. So we can pull these exponents out front. And when you do that, you get 3 times log base 2 of x plus 2 times log base 2 of y plus z minus 5 times log base 2 of w plus 1. So there's our first sample problem here with expanding logarithms. Let's go on to another one here. We're going to expand log base 9 of xy plus 2 all to the 4th divided by x minus 7 raised to the power negative 2 times y minus 2z. Again, we're expanding, so we need to start off with the quotient property. We clearly have a quotient of things happening, so it's going to be log of everything on top minus log of everything on the bottom, and that puts us right here. As we see, log base 9 of everything on top minus log base 9 of everything that is on the bottom. Now, product property. There's no product happening here, not a clear product of two separate things. Here, though, there is a product of two separate things. The x minus 7 to the power negative 2 and the y minus 2z. So we're going to take this logarithm and break it up as the sum of 2, giving us log base 9 of xy plus 2 raised to the 4th power. That term carries down. Now it's minus log base 9 of x minus 7 to the negative 2 plus log base 9 of y minus 2z. And note that I have the parentheses around the outside of the sum of both of those terms there. We had the minus sign in front of this thing here. Since what's inside here is equal to the sum here, this minus sign does and will end up being multiplied into both of these terms here. So be very, very careful when you see something like that. If you have the product of two things on the bottom of what's inside of your log, when you use that quotient property, that minus sign is going to be multiplied into both things that were on the bottom. And then lastly, we use our power property. We have an exponent here, and we have an exponent here, so we're going to take those powers and move them out front. So we have 4 times log base 9 of xy plus 2 minus the quantity, the negative 2 came out front to give us negative 2 log base 9 of x minus 7 plus log base 9 of y minus 2z. We then multiply that minus sign into each of our two terms, giving me 4 times log base 9 of xy plus 2 plus 2 log base 9 of x minus 7 minus log base 9 of y minus 2z. So this one, a little bit more tricky, but overall not too bad here. These were our two sample problems where we expanded a single logarithm into the difference or sum of multiple. Now let's go the opposite way. Let's take the difference or sum of multiple logs and we'll condense them into one. So let's condense the following logarithms into a single log. Here we have 5 times log of 2x plus 1 plus log x minus 6 log of x minus y. Just as a recap from the previous video, if you don't see a base on log, then you assume that the base is 10. So going back to our chart of what thing did we do first, since we're condensing, we're going to use that power property first. And we're going to take the numbers that are out front here, and we are going to make those the exponent of what's inside of our log. Now note that there is this minus here. You could take the sign as well, but you don't have to. There is more than one correct answer you could come up with at the end. I will say, although it may seem like they're different answers, they actually are all the same answer. It's just that the form it takes could not be quite the same. So when we use that power property, we arrive here. Log of 2x plus 1 raised to the 5th power plus log x minus log of x minus y raised to the 6th power. Next up is our product property. If you see a plus sign in the middle of two logs, you're going to look at those two logs and you're going to rewrite it as the log of the product of the things that were inside those two logs. So I look here, I see those two logs being added up there. So I'm going to rewrite that as log times x of, log of x times 2x plus 1 raised to the 5th power minus log of x minus y raised to the 6th. There's no other pluses happening here, so we can continue on. Just as a quick note, if you saw the sum of 3 logs happening right next to each other, you could use that power property to write the log of the product of those 3 insides. But for this problem, we only now have log of something minus log of something else. Going back to our 3 properties, the difference of the logs is equal to the log of the quotient of what was inside of those 2 things. So I can take this thing and rewrite it as such. Log of x times 2x plus 1 raised to the 5th power divided by x minus y raised to the 6th. Moving on to our next one, we're going to condense this guy here. 7 times ln of 3x minus 2y minus 2 times ln of x plus z plus 4 times ln of z plus w. Once again, we're condensing, so we're starting off with the power property. The numbers out front are going on the exponents, or are going as the exponents of what we have inside of our logarithms. And that puts us here, natural log of 3x minus 2y to the 7th, natural log of x plus z squared, and natural log of z plus w raised to the 4th power. Now note that I switched the order of these two terms here. I put the plus natural log of z plus w to the 4th, and then the minus natural log of x plus z squared. The order in which we put these terms does not matter. But when you can, change things so that you have any terms that are being added next to each other, and then any terms that would be subtracted next to each other as well. So we can use the subsequent properties a lot easier. Next up, we have the product property that has to be used. I see the sum of two logs here, so I'm going to rewrite that as the log of the product of the things that are inside there. And that's going to give me natural log of 3x minus 2y to the 7th times z plus w raised to the 4th minus the natural log of x plus z squared. Lastly, quotient property, I see the difference of two logs. I'm thinking, okay, that's equal to log of the quotient of those things. And we have ln of 3x minus 2y to the 7th times z plus w to the 4th, all divided by x plus z squared. So these two examples that we saw here are kind of middle of the road to the slightly more challenging side. It could get a little bit more challenging, but this is pretty much par for the course here. As far as problems you could see from me on a homework or quiz or test regarding condensing and expanding logarithms as well. But this is how we use those properties to do both of these operations, expanding or condensing. There are several common errors that people make when they work with these properties of logarithms. Do not make the following errors. I could say this until I'm blue in the face and somebody will still make the error, but nonetheless, if I go down swinging, then I shall do so. So do not make the following errors. The log of the difference or sum of two things is not equal to the difference or sum of those logs. That's number one. Number two, the log of the product is not equal to the product of the logs. Similarly, number three, the log of the quotient is not equal to the quotient of the logs. Number four, if you're taking the quotient of two logarithms, you cannot rewrite that as the difference of the two logs. It has to be the log of the quotient, not the quotient of the logs. The order of those words does matter. And number five, this is a fairly common error as well. If you have something times something else raised to a power, and you're taking the logarithm of that, people make the common error of taking that power of p that was only on one of the terms and not both, and pulling that power out front. That is not the case. You cannot do that. That is not true. So you can only pull a power out when the power is applied to everything that's inside of that logarithm. There is a fourth property that I do want to mention. Mainly it's used to evaluate some nasty logarithms and to solve exponential and or logarithmic equations, which we'll talk about in our next video. This property is called the change of base property. Maybe some of you have heard it. But if you have log base b of m, that is equal to log m divided by log b, or natural log of m divided by natural log of b. Now, realistically, we could use any new base that we wanted to whatsoever, but typically when you're solving these kinds of problems, it's something you have to plug into a scientific calculator to solve, and the two logarithm buttons that we have on a calculator are the common log or the natural log. So go with either one of these two. Which one you use, it does not matter, because you should come up with the same answer in the end. Here's an example of how we would use this thing. Log base 5 of 100. If you think back to the previous video, in converting into exponential form, really what we're saying is, what power do I need to raise 5 to get 100? And that's not very obvious. It's not very clear. So this is where that change of base property comes in handy. So saying log base 5 of 100, I chose to use the natural logs here. This is equal to the natural log of 100 divided by the natural log of 5. You can take each of these numbers, calculate them in your calculator, and then take the quotient, and you get approximately 2.86135. So close to 3, but not quite 3. And if you think about it, that makes sense, because 5 squared is 25, 5 cubed is 125, 100 lies somewhere between 25 and 125, and it lies closer to the 125. So that's just a little bit of checking your answer, seeing is this a logical answer. But mainly we're going to be using change of base property in the following video when we talk about solving exponential and logarithmic equations. But this concludes our video on the properties of logarithms, product property, quotient property, and power property. Guys, if you have any questions or comments, please be sure to reach out to me. Email, snail mail, text, phone call, signs on blimps above the Orange Bowl on New Year's Day, bonfires on the beach as an SOS. Whatever you have to do. Until the next video, take it easy, guys.